Thank you, Lisa, for those wonderful compliments. I thought I'd begin by relating a brief sort of anecdote about myself, a little episode from my history that sort of introduce myself to all of you and explain a little bit about how I came to be here. My background is in engineering. I had a few odds and ends engineering jobs and spent many years in school studying engineering. One of the courses that all engineers take is thermodynamics. Now, if you ask a list of college students for the most boring, useless, stultifying, mind-numbing course that they can list, I bet thermodynamics is going to be pretty close to the top of the list. I took it as an undergrad and remembered absolutely nothing. I'd forgotten that I even took it. But then I came back to grad school and I started teaching. And I realized pretty quickly I needed to re-educate myself. The book was useless. I told someone once that you could learn more about thermodynamics by burning it than by reading it. So I decided I had to go to the library and start looking for better books, for a better source of thermodynamics. And I found it in dust-covered, cracking, crusty books on the antique shelves. I fell in love with old books because I discovered if you read books that were written 50, 100, 200 years ago, they are beautifully clear. You get to see the development of things. You get to see the reason why the laws take the forms they do, especially if you read something by one of the original scientists who actually made these discoveries. You get to see what the context is, how these things came to be, why we say the things that we say, and why we do things the way that we do them. So that was sort of my first experience. That's when it really sank in. There's a good way to learn things and a bad way to learn things. You can learn things by being told and you memorize them, or you can learn things by being shown, by elaborating, by thinking them through. That was my, I didn't think of it in those terms, but to borrow Feynman's terms, that was my sort of discovery of the difference between knowing the name of something, the law or concept or whatever, and actually knowing something about it, knowing the law of thermodynamics or the concept of thermodynamics or whatever. So I ended up teaching thermodynamics at various levels for several years, and some of my fondest memories are of those experiences. And among other reasons, that experience is what led me here to VDA to attempt to develop my own science program. So that, sort of in brief, is Mr. Krieger, thermodynamics. Now, what about your child, science student? What kind of experience do you want your child to have in science class? Do you want it to be like my first experience in thermodynamics, where you have no idea what you're hearing, you can't tell what a protein is, it's just words that you're memorizing? Or do you want it to be kind of like what I discovered in those old books in the library? Fascinating, relevant, something that enables your child to actually walk through the world and say, oh, I get it, I understand, it all makes sense, I feel at home in the world. So, those are sort of the two options. Now, to illustrate, the first one is option number one. I happen to have a conventional textbook here. This is a life science textbook aimed at 7th grade, published by a standard big curriculum publisher. It has 5 authors, 20 consultants, 28 associates, and I think about 20 reviewers. And on every section, they list very carefully which of the Department of Education, the state of California, science standards it is supposed to be in alignment with. So it's got to be good. The chapter 1 begins here after about 40 pages of telling you how to use the book, and about 30 pages of miscellaneous vignettes on the topics. I thought what I would do is, we were talking about, actually I was tempted to do what Feynman did with the Brazilian physics textbook. I could do the same thing with this book. Just pick a random page and read something and show you that it's memorizing, but there's a 50% chance I'd land on a giant graphic or a pop-out window, something equally useless. But what I thought I would do is, we were talking about the eye recently in science class, so I thought I would read to you their description of how the eye works. They spend about 6 pages on the eye, but the basic description of the basic function of the eye comes down to one page. Now, I'm going to ignore this column on the left-hand side. The top, this is the list of all the state science standards this lesson is supposed to support. 5G, 6B, 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 whatever. This is a reading guide, so in case you don't understand what you're reading here, this will tell you what you're reading. Here's why it's important. So if you don't get it, you have no motivation. You read this, and that'll motivate you. Seeing is an important way people learn about the world around them. Feel motivated? And then some vocabulary at the bottom. So throwing that aside, and actually going to the text. Here's the text of how the eye works. The eye and vision. Main idea. The eye is a complex organ made up of different parts. Real-world reading connection. Cameras, telescopes, and microscopes all use lenses to form images. Did you know that your eyes also contain lenses? Like other optical instruments, the human eye uses refraction to form images. How the eye forms an image. So if you're going to pick out the really explanatory part here. Your eye detects light that is emitted by or reflected from objects. In some ways, an eye is similar to a camera, as shown in Figure 24. In a camera, light from an object enters the lens. The lens forms an image on the film or light sensor at the back of the camera. The film or light sensor then records the image. As light enters your eye, lenses in your eye focus light to produce an image on the back of your eye. Special cells at the back of the eye convert the image into electrical signals. These signals then travel to your brain, where they are interpreted as the object you are looking at. Now that's sentences. They're more or less accurate. But is that really an explanation? I want you to notice something about what they've done here. Every sentence in here is just a plain, bald assertion. They just state something, and you're supposed to memorize it. There is no pointing to anything in the world of the child. There's no observation. There's no comparing or contrasting. There's no searching for exceptions or implications or patterns. There's no mental activity going on in the mind of a child other than memorize. The only mental activity that your child can perform with this is memorizing.